Design of light gauge steel frame for building structures with FrameCAD structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
In this section, we shall insert the TRUSS uplift plan, and then we shall also see what insert in the drawing, the lateral load generated and the lateral resistance in the drawing itself. So, to create the uplift plan, we need to bring the truss border layout having the trusses on the focus. So now you can see that truss is on the focus. Then the command to create the truss uplift plan is DUP. So select a location within the border for the truss uplift plan is the message on the status bar. So let us select on a border. So inside a border, we are selecting the top one. So click on that. So you can see the truss uplift plan has been created. So these are the truss reaction. So we should go back to our original calculation and see whether this reaction is more than what we have calculated in the Excel sheet. You can see the truss uplift is 1.61. We have what we have calculated as per wind load or wind uplift as per Indian code. So in FrameCAD file, you can see these reactions are more than that. Obviously, we have all kept the FrameCAD wind load quite on conservative side, because the coefficient that of the wind pressure or everything that is being assumed by FrameCAD is usually on conservative side. So our trusses are safe. So now let us insert the bracing reactions. So let us select the ground floor walls, bring the ground floor walls in the focus, then write the command PCB, go to detailing option, create bracing plan, click on that, then click on insert. Now status bar, on the status bar it is asking select location for bracing plan. So we select this border, click. So you can see the reactions generated by the braces D. The K braces is given and the strap braces are also given. DS indicates strap braces and K indicates K braces. And similarly, we should insert the reaction for the first floor plan also. So bring the first floor plan on focus. Now again write PCB, detailing option, create bracing plan, check create bracing plan, insert. Now select this border, click on it, So you can see the bracing plan reactions has been given. So for this we have provided on single strap. So you can assess these are DS indicates double strap, SS includes single strap. So there are single strap here, and here we have provided only 4 numbers of strap bracing here. Now we should also include in the plan the bracing resistance and the lateral forces included. So bring the ground floor plan on focus, go to PCB, write in the command bar PCB, then enter, go to detailing option, insert wind forces. These are the wind forces generated because of wind lateral forces. So we place it here, applied wind forces, and then again go to command bar, write PCB, enter, go to detailing option. Now insert raking resistance, click on insert. So let us place it here. So our raking resistance is more than the wind forces. Similarly, we should go to the first floor as well. Again, bring first floor in the focus. Again, PCB. Detailing option. Insert insert wind forces, check insert wind forces, then click on insert. So applied wind forces on first floor is also given. Then again PCB, on command bar enter, detailing option, insert raking resistance, check insert raking resistance, then click on insert, place it at a suitable position. So our raking resistance is more than the lateral wind forces generated. See, at times for this building the resistance provided by the strap braces and the key braces are enough, but at times we must include the resistance provided by the mild steel structural frame, so that whatever is being deficient, that can be covered by the lateral resistance provided by the mild steel structural frame. The next section is to know the weight of the wall panels, etc. has been created, all the accessories. So from layout, let us go to the panel tab and then type REP report. So you can see the summary report. The total weight in kg is given. This excludes fixing. This is material report. Then this is panel wise weight. So we can print them all, print all, Microsoft to PDF, So we can save them in our desired folder. Let us make a folder, reports, and panel, save as panel report, save. So it has been saved. Then let us go to the floor. Again, type report on the rep on the command bar. So we can give same command, print all. Click on same button, print all, Microsoft to PDF. Then joist report. Then go to the TRUSS. Again, type report on the command bar. Report. You can see the TRUSS report. TRUSS each TRUSS weight in TRUSS. Then material report. Then summary report. Then engineering status is also given. So print all. Microsoft Word, TRUSS report. Save as TRUSS report. Now you can go to the folder. Our folder was whatever folder was there in which we saved it. F report. So this is panel report. See, this is the file which has been created by FrameCAD. All the details are there. Panel edges report, panel edges report. So this is panel summary. Similarly, if you want the design report of any particular panel, say I bring this panel into focus and type PPT. So start design report is there. It will show the max start spacing required as per the forces. So it should not be less than 1. So this is one thing which 0.42 WCC. This is one thing which we should actually check manually, because with cement board it has been found that the deflection is reduced by only 30%. So we should reduce the wind load by 30%, not by what the percentage shown here. Here it has been reduced by 58%. Probably it is because there are some changes in the IBC wind loads. So, even in an experiment performed by a reputed institute, we have found that the lateral deflection due to wind pressure, lateral deflection of the strut due to wind pressure is about 70% because of the presence of the sheathing that is in the form of boards, cement boards. What it should have been if we calculate the lateral deflection due to lateral pressure due to wind. Now what do I mean? Now I have a vertical stud like this. So this is a floor, and there is a support at the bottom in the form of anchor fastener. So wind load will be acting on this stud. The magnitude of wind load on the stud will depend upon the system. Now it will deflect like this, something like this. So this is the deflection. This deflection should not exceed h by 240, where h is this, should be less than h by. Now when we calculate this deflection, we should apply 0.7 design pressure PD instead of 100% pressure. So this 30% reduction in this local lateral deflection is due to the presence of the sheathing around the on both sides of the stud. Bill of material of this particular wall could be found here. Fabrication drawing can be found here. So if we can print it, there is a print option here. If you want, we can print it. Similarly, if you go to the floor, you can bring into focus any of the joist and then type JJD on command bar. So showing engineering off. For a side bearer, the engineering will be off. So let us select a floor joist. This is FJ6. So let us try on it. So bring this joist onto focus. Now type JJD on command bar. Now if you see engineering status 85%. Now we can print it as well. Print. Summary, add. Continue. OK. So joist design report. Save. Now if you go to the folder, reports, you can see the joist design report is printed here. Similarly, we can go to the trusses. We can select any critical trusses for which we need to check, or we can select few critical trusses one by one for submission of design report. So let us select this truss, say T3. So after selecting, if the command bar hides, you can click on the bottom bar, command bar will appear. So bring this into focus. Now type TTD. So you can have truss result, then detailed design drawing. So you can print it for submission. Engineering is also given here. So what is criticality is being shown. . With this, we have finished the design of light gauge steel structure with FrameCAD software. But in practice, it is only FrameCAD which is providing a designing package along with the detailing package as well. But most of the LGS frame making vendors do not provide the designing package, even if they provide. So they provide an option to export to software, structural software like SAP or something like that. The issue with those software is that they develop movement about the minor direction, which actually very negligible when there remains cement board or bison board on both sides. So if you see EISI design example, it is only the movement about the major direction which is considered for design. The minor direction movements is very negligible whenever there is a presence of board on both sides. But the structural software will always analyze a bare frame, so it will develop movements about the minor direction. And the other issue is that if our trusses or joists are spaced, say, around at a different spacing, so UDL, uniformly distributed load, will not be generated by those softwares as a reaction. Was because of the presence of sheathing on the both sides of the wall. Actually, the load transfer to the base is actually in the form of UDL. You can say at most the reactions at the lower end of the studs, vertical studs, are more or less equal. What is structural software analyzing a bare frame will not produce that effect. So we shall try to learn how to design light gauge steel frame structure with the help of manual calculations, because most of the machine do not provide the design packets with them, so manual calculation has to come. For that, we can take help of software like Stud Pro also, and we have to make some tweaking in the soft oil modeling so that the reactions transferred to the base is more or less equal, and we can take the forces for bracings and etc. from the output of the software like Stud Pro or ETAPS and design for those things. While preparing the erection drawing, the next part of this is preparation of erection drawing. While preparing the erection drawings, the layout drawing will be sufficient. We have to provide the dimension, but the thing is that looking at the reactions, we have to provide some hold downs at locations wherever the bracing reactions are quite hot. So two types of hold downs are usually provided: HTTP4 and HTTP5. This HTTP4, HTTP5 hold downs detail can be found with Simpson strong tie. You can search in net and find it. I shall provide some typical erection drawings in my website. You may download it and study those drawings, how the erection drawings and the detailed drawings to be given to the site should be prepared. So, in next section we'll cover one or two little things, and with that the design with FrameCAD software example should be sufficient. After that, you should be able to model, and the next step after completing the modeling is to export this file for CNC machine. If you practice this much only, you will be able to model LGFS structures, model and design LGFS structures in FrameCAD. And so now let us save our model. File, go to save, and then exit.